In this video, we'll learn a new term associated with graph theory and uncover one of the most famous formulas in the history of mathematics. Here we have a connected graph with no crossing edges. It has 9 vertices and 13 edges. It also has a feature that we'll call regions. Regions are spaces that are bounded by edges, and we also consider the, quote, outside of the graph a region as well. So, in this case, for this graph, we have a total of 6 regions. I'll be showing how to build graphs with a variety of characteristics, and then asking you to create some on your own. If we look at the row for graph A, we see that we're given requirements of 5 vertices and 6 edges. I'll begin by drawing the 5 vertices. Next, I'll connect the vertices to add a total of 6 edges to the graph. Notice that the row for graph A is missing some information. It's missing information about regions. So, as we count the number of regions, we should enter a 3 into the table. Now it's your turn. Stop the video, create graph B, and record data in the table. Please remember that your graphs should have no crossing edges. If edges cross, you need to put a vertex at that intersection. Go to it. Welcome back. Let's move on to graph C, which we're told should have 4 vertices and 4 regions. Again, I'll start by drawing 4 vertices. Next, I'll begin connecting vertices with some edges, and at this point, I notice that I have only 2 regions so far. I'll need to add some edges to increase the number of regions. If I draw 2 more edges, creating some parallel edges, I find that I can meet my requirement of 4 regions. Now I need to count and record the number of edges for the graph. In this case, we see that there are 6 edges to the graph. Your turn. Stop the video, create graph D and graph E, recording missing data in the table. Don't forget about avoiding those pesky crossing edges. Welcome back again. Let's drop down to graph F. Here we find requirements of 7 regions and 12 edges. Rather than start from scratch, some view this task as more challenging without knowing the number of vertices. So let's recopy the last graph, which we know had 4 regions and 6 edges. So let me add a few more edges and try to increase the count for both edges and regions. If I draw 2 more edges, I can increase the edge count to 8 and the region count to 6. Let's keep going and add another edge cutting through the middle of the graph. That way, I'll get the required number of regions, 7, and my edge count increases to 9. I still need to add some edges though, but I need to do it in a way that doesn't create more regions. If I add some spokes coming out from the graph, notice I'll not create any new bounded regions. So I can add 3 spokes, increasing my edge count to 12, but my region count is maintained at 7. So now I need to determine the number of vertices. It happens to be 7, and I'll record that in the table. One more graph for you to create. Make graph G and record the data in the table. Do I need to repeat the warning? Now that we have all of this data, let's look for some patterns or trends. See if you can determine how the vertices and regions are related to the edges of a graph. If you find a relationship, you rival the most prolific mathematician of all time. You've uncovered Leonhard Euler's characteristic formula. Lenny would be proud.